Welcome to this project showcase for the course Neural Networks. This is Ajay and I'll be running you through a project entitled A Deep Learning Approach for Live Cricket Score Updates. My team consists of three members, myself, Sai Krishna Rajaram and Narendra Nangarajan. Now let's take a look at how deep learning can be leveraged to enable an automatic cricket score update using umpire gesture sensing and neural networks. The idea is pretty straightforward. Initially, we use the dataset, which are typically the umpire's signaling images, to train the baseline model and validate the same. In real time, however, the trained and tested model recognizes the umpire's gestures and updates the scoreboard accordingly. This project, nevertheless, focuses only on training and validating a neural network model for this purpose. A good future addition for this project could be to count and update the score from a live video or a standalone video and sample the video frames and recognize the umpire's gestures and update the scoreboard accordingly. In this project, for a baseline model, we created a convolutional neural network using TensorFlow and Keras for image classification tasks. The baseline model's architecture is inspired by the popular VGG network but designed to be compact, suitable for resource-constrained environments. We have implemented a tiny VGG model consisting of convolutional neural networks followed by max pooling layers to extract the features from input images. With two sets of convolutional and pooling layers, the baseline model ensures a robust feature extraction while keeping the model lightweight. The final layers of the baseline model include a flattening operation to prepare the data for classification and a dense layer with softmax activation for multi-class classification. After defining the baseline model's architecture, we compile it using the Adam optimizer and categorical cross-entropy loss function with accuracy as our evaluation metric. Such a baseline model equips us with an efficient tool for image classification tasks. Okay, now let's take a look at some of the visualizations. Here, we have the data classification represented in a visual form. The picture depicts how the dataset is classified for each segment. For example, the very first image shows a cricket umpire without any gestures, thus no action. Likewise, the second image shows the umpire signaling a no ball, where he stretches one of his arms. Similar is the case with other classifications. Totally, there are 5 classifications, and they are no action, no ball, out, sixer, and wide. The loss and accuracy of the baseline model is depicted visually as a graph. The baseline model prediction is presented here. As you can see, the baseline model is not the most accurate when it comes to predicting the umpire's gestures. While the baseline model predicts 3 sets right, there is a good enough scope for improvement. The baseline model, while it had a validation accuracy of 46%, as I previously said, there's a huge scope for improvement. The improved model consists of multiple layers has resulted in 15 to 20% increase in validation accuracy compared to the baseline counterpart. However, we are still working on improving the model further to push the validation accuracy even up. Hopefully, we can reach the higher 80s. Alright, we have come to the end of the presentation. Please feel free to drop your questions to atherma2 at ncsu.edu. We will get back to you as soon as possible. Thank you for your time.